All right, guys. So, listen, I'm sorry that I have to do it this way. Apparently, on January 10th, I'm sorry, um, Google took away the ability to record a Google Meet, which is normally how I do this, and it works a lot better. This is probably going to show up as a really small image on your screen. If that's the case, guys, I will expect you to. I'll post the presentation along with it, so that you can just open it up and you can use this almost as a little audio recording. For those of you who are just logging in to get the points, I will have a question for you embedded somewhere in this presentation. Obviously, I'm not going to tell you where that is, so that hopefully you watch as much of this as possible or listen to as much of it as possible. But I'm going to try to get this done as soon as I can. I don't want to keep you for a super long period of time here, and I believe we left off. We finished the 3 R's. This is still on waste, by the way. I believe we left off on composting, compost piles. And again, I do think this is going to be rather tedious on my phone. So, regardless, like I said, if you can't see this, go ahead and open it up on your computer and then just listen to it. But again, you guys know what composting is. I don't think I need to get into too much detail. This is another way to deal with organic, specifically organic waste material. You can't put plastic jugs in your compost pile or something along those lines. It has to be something that's going to be broken down over time under controlled conditions. And usually, this is actually a really good thing to do. In 2 to 3 months, you get very rich, sort of fertile organic material that has been decomposed now. And a lot of people have these in their backyards, and they'll take like trimmings. Like I do a lot of cooking, and anytime I have leftovers, or if I have just pieces from vegetables and things like that that aren't going to be consumed, stems, seeds, they'll go in a compost pile, or I'll just throw them outside for the birds. But composting is a great way to rid ourselves of waste that shouldn't go in a essentially lifelong plastic bag and sealed into a landfill. This is a great way to avoid that landfill space, which is really what we're after. That brings us. Speaking of landfills, let's talk about them a little bit. I've talked about it before. This is the primary destination for all municipal solid waste. I've talked about it before. I can't believe that this is our best solution. To basically just take all of our thrown away material and to essentially just put it in a hole and cover it up with soil. But that's what we've been doing for a really long period of time. We used to actually put our waste oftentimes in waterways, so we would just throw it in the river. Thankfully, we've went away from that, and now we do I guess the second best option, which is to throw it in a big hole in the ground. The problem with this is what's called leachate, which is a liquid that contains elevated levels of pollutants. As a result, basically, the way that I think about leachate is that kind of liquid at the bottom of a trash can that's been sitting out for too long, or maybe the liquid at the bottom of a trash can bag. Imagine that just on a giant scale. And a lot of times, not only do we get that we have to deal with, and that's why these landfills have to be lined, but we also get gases that are given off as some of that organic material actually decomposes. And that has to be oftentimes captured so that it doesn't just create more greenhouse gas effect. So what we are attempting to do, what we are trying to do better in regards to landfills is what are called sanitary landfills. These are engineered and designed to hold municipal solid waste with as little contamination to the surrounding environment as possible. Essentially, they are clay tombs, and we're trying to minimize the amount of water that gets into it, because the more water that it has, the more leachate it's going to have. However, the leachate that it does form have pipes that collect it and transport that, and then so it can be processed. It's much more discerning as to what goes into the landfill. However, just with any sort of solution that we come up with, they're obviously very expensive, and they're a big undertaking. And honestly, landfills are just overall kind of issues that we have, I feel like, in our society, because no one wants to be next to a landfill. No one wants to have their town located near one. They can't be around waterways because water is much more likely to seep into them. they're the worst solution I feel like we have to a very global problem. And the question is, what can we do? How can we make this better? And one of the arguments for that, again, if I'm going too fast, guys, feel free to pause this so that you can get what you need. But I'm trying to not, waste a ton of your time. I'd like to get through as much of this as I can. Actually, I'm going to get through all of it, but to get through it, and that way you don't have to mess with it for any longer than you need to. But one of the things that we can do is we can incinerate our municipal solid waste, and this is something I wish I'd see more of. And trust me, if you're sitting there already thinking, well, there's got to be issues with that, you're absolutely right. There is a lot of problems with burning things. But we do it all the time. I love how that argument is kind of odd to me, because we burn coal and other fossil fuels for the sake of energy. So why not burn something that we're going to throw away anyway? I think that argument is silly. When 75% of all MSW is combustible, and we can reduce that volume, reduce waste volume by 90% with this. Of course, it produces ash. And a lot of times, like I said, you can use this heat, by the way, to generate electricity. You're not just burning it for the sake of burning it. You can actually have this as a part of a power generating facility, as a part of a power plant. Now, of course, like I said, there's going to be contaminants. There's going to be air pollution that's involved with that. There's going to be ash that has to be disposed of. And that ash is often sent to the landfills, and that air pollution is often scrubbed and then released into the atmosphere. But we're still generating a lot of that energy in the same means anyway. We might as well burn something that we no longer have a use for. So I definitely think there's a value in it. I'm going to play this video. Hopefully it'll come through and you guys will be able to hear it. But it's a really good video. But there's 2 videos today, and both of them are very good. Hold on. Of course I'm not. This is what happens when you try to do this on a phone. It's just ridiculous. Oh my gosh. There we go.
My solution to most of my problems is to light them on fire. So why can't garbage be one of those problems? Hi, I'm Julian. This is D News. Americans make a lot of trash. According to the EPA, in 2012, the average person made 1,600 pounds of solid waste that year. That's about 45% more than the average European. About 55% of that goes in a landfill. So to translate that, if you're an average American, you were responsible for burying 880 pounds of trash in 2012. Is there something that garbage could be doing besides just sitting there? Sweden thinks so. About 1% of Swedish trash ends up in a landfill. The rest is almost evenly split between being recycled and burned for energy. Sweden actually burns so much trash, they import 700,000 tons of it from Europe in order to keep the fires lit. And by using the heat to create steam and run turbines, they get about 8.5% of their electricity needs from burning waste. Goran Skoglund, a representative of one of Sweden's energy companies, estimates that burned trash has about a third the energy pound for pound as burned fossil fuels. Burning that trash means they save space in landfills, don't need to import fossil fuels, and as an added bonus, they cut down on greenhouse gases. All right, stop right there because I know exactly what you all just yelled at your computer screens. Julian, burning anything is going to create CO2. And yeah, you're right. But like a Swedish police drama, it's all very nuanced. On the face of it, burning garbage actually looks less favorable than coal or natural gas in terms of CO2 production. According to the EPA, flaming trash creates 2,988 pounds of CO2 per megawatt hour. For the same power, coal makes 2,249 pounds of CO2, and natural gas makes 1,135 pounds. That doesn't sound good until you consider that a lot of the CO2 released by burning trash is from stuff that was part of the Earth's carbon cycle. It's carbon that was in the air not too long ago and would be returning there again, whereas the carbon released from burning fossil fuels was out of the carbon cycle for millions of years, sequestered away deep underground. So the EPA considers the CO2 impact of burning waste to be about a third as bad as it looks. But energy from garbage unequivocally cuts down on a much more insidious greenhouse gas, methane. Methane doesn't stay in the atmosphere for hundreds of years like CO2 can. Usually it's out in about a dozen. But this little molecule is so good at trapping heat, the EPA estimates one CH4 has 25 times the impact as one CO2 over the course of a century. And do you know what the third biggest source of man-made methane is in the United States? Landfills. Yep, 18% of the methane Americans make happens when we bury our trash and let microbes just go to town on it. Methane is a key component of natural gas, so some landfills capture it and sell it to power companies. You'd think the trade-off would be reduced methane for increased CO2, but the number one source of methane emissions is natural gas and petroleum systems. So you don't get that methane when you burn junk, and as a bonus, you don't have to burn as much natural gas or coal. Double win. Flaming heaps of trash isn't as totally glamorous as I'm making it sound, though. Like anything, it has its own foibles. It cuts down on greenhouse gases, but the trade-off is it puts other pollutants into the air. Sulfur dioxide, which causes acid rain, is released, along with trace amounts of mercury compounds and dioxins, which are highly toxic and build up in fatty tissues. Concerns over these chemicals are the main hindrance to adoption in the US, along with nobody wanting a trash burning facility in their backyard when there's lots of cheap land. Sweden strictly regulates all these toxic byproducts, and even so, plant representatives say their scrubbers reduce toxic chemical levels to half the legal limits. Some of these byproducts would still be present in landfills too, only they'd have the potential to seep into groundwater if the landfills aren't equipped with a protective lining. Environmentalists who oppose burning trash argue that the goal should be to reduce how much waste we make in the first place and recycle more. And they're absolutely right. But there's no evidence that burning waste will hurt recycling efforts. Sweden is expecting to step up recycling from 50 to 60% in the coming years, and they're only burning what they can't use. Even though the US buries most of our trash, we only recycle 34% of it. So, even though it's not glamorous and not the cure-all for our refuse and energy woes, it looks like burning trash could actually be an important stopgap for climate change if it were more widespread. Egypt deals with its junk in a rather unusual and interesting way. Lizette and the team at our sister channel, Seeker, cover that right here.
Individuals pushing carts pick up most of the garbage, and this system works surprisingly well. Almost 90% of materials thrown away in Cairo are recycled.
Where do you fall on the burning trash issue? For it, hate it, have some reservations about it after Toy Story 3? Let us know in the comments. Subscribe if you haven't already, and I'll see you next time on D News.
All right, so I'm hoping that... See, I don't understand. I'll be honest with you. I do not know how to navigate through these on my phone. All right, so incineration, like I said, it's not all good. It does produce greenhouse gases, but as Sweden is showing, most of the greenhouse gases are offset by the fact that those would still be produced if they were rotting, essentially, in a landfill. They're very expensive to build. And there is an argument, I again think it's a silly argument, but as that gentleman just said, there is an argument to be made that it would stifle recycling efforts. But that brings us to maybe the most devastating of all waste materials that we have to deal with, and that is hazardous waste materials. There are four main characteristics of what is called hazardous waste: ignitable waste, corrosive waste, reactive waste, and toxic waste. And this whole process of hazardous waste, the way that we handle it, is controlled by the Superfund Act of 1980, which imposed a tax on chemicals and petroleum industries, or and petroleum industries, to allow for cleanup of hazardous waste sites that those companies probably had a hand in creating. Those hazardous waste sites are often referred to as brownfields. And they designated, this Superfund designated and put a public list together. You could look up this list today. You could put a public list together of where these brownfields are located. These include contaminated industrial commercial sites that may require environmental cleanup in the process of hopefully ridding themselves of them. There are 450,000 of these and 1,000 just within the city limits of Chicago. Both of the ones that I have pictured here are actually from Chicago. So you can go to these brownfields, and these are just sitting there. They are contaminated with hazardous waste, and we just have not done the cleanup effort to allow those to be reused, resold, and repurposed into hopefully something better. But the thing that I find most interesting about this entire chapter, and go into your book, I know you guys aren't going to do it, but go into your book and read this portion of it for this chapter. It's the idea of life cycle analysis, tools that examine the materials used and released throughout the lifetime of a product. Because one of the things that we do as a society, and it's a failure of ours, is that we look at a product and decide if it's good or bad for the environment based off of one aspect of its life. We might say, oh, well, this is a much better product. It's much more biodegradable, for example. But let's say maybe that product, whatever it is biodegradable. Maybe it's a storage device or storage container for leftover food. Okay, it's biodegradable. Great. Okay, it's not going to cause any issues. But what if the process of manufacturing that biodegradable product is incredibly invasive to the environment, incredibly bad for the environment, and more so than even a styrofoam cup or a styrofoam container? You have to look, the point is you have to look not at just a single aspect of a product, but you have to look at it as a whole, overall, to see, and that is called the lifetime of the product, or a lifetime analysis, life cycle analysis of that product. And that goes into this idea of the paper plastic argument. So this is becoming less and less likely, but if you go into a store, oftentimes in the past they used to ask you if you wanted paper or plastic. Most of the stores I go into anymore, a lot of times you even have to pay for which one you want. But a lot of people would argue, oh, I'm going to take the plastic, or I'm going to take the paper, rather. That was the first argument. The paper is recyclable. It's better. Today, it's all about bring your own bag in. And if you guys were here, I would ask if any of your parents have, those little plastic totes that they carry around, and they bring their groceries to and from with those totes. So, and that brings us to the idea, we're going to talk about that life cycle analysis a little bit more, because the paper plastic argument is very interesting. But that brings us to the idea of the integrated waste management system, which employs several waste reduction and management strategies and disposal strategies to help reduce the overall environmental impact of municipal solid waste. But I'm going to leave you guys with this video, and I think this is a really interesting video. And by the way, before I do it, I'm going to do the question for the day, which is, what is the first name of the gentleman in the D News segment that we just watched? I want you guys to comment, there's a question associated with this assignment. I'm putting this video in as an assignment, so you can answer that question. What is the gentleman's name in the D News segment that we just watched? So I'm going to play this, and guys, watch this last one, because it's a video, it's a good video, and I promise you it's very interesting, because some of you guys have that plastic tote, or that cloth tote, I think, in this example, and I promise you it's not as good for the environment as you might think. I'm going to try to play this again. Here we go. Wow, that didn't work out. Cancel.
We all want to make greener choices and help the environment, but sometimes what's best for the planet can be counterintuitive. Like single-use plastic shopping bags seem to be quickly going extinct. They are now banned by stores, cities, even entire countries. And in their place are sturdier, reusable, supposedly greener bags. So problem solved, right? Well, when you look at the entire life cycle of a product, what's best for the environment can get complex. Case in point, by some measures, plastic bags can be the best option, at least if you leave out one important factor. There are all kinds of bags out there, but here we will focus on the 5 most popular: single-use plastic bags, single-use compostable or biodegradable bags, brown paper bags, and 2 kinds of heavyweight bag: thick reusable plastic bags and the classic cotton tote bag. From that list, you might think you know which bag is best, but sometimes our intuition does not line up up with reality. And that becomes clear when you look at the life cycle assessment for this. A life cycle assessment is a study that looks at the full environmental impact of a product. In it, researchers study and add up each step in how a product is made, used, and disposed of. Several studies have been done like this, and the overall conclusions tend to be the same. But one major report was prepared in 2018 by the Danish Environmental Protection Agency. This report looked at two types of impact: climate change and total environmental impact. The climate change bit was pretty straightforward. They added up all the greenhouse gases emitted throughout the lifetime of these bags. Now, not all greenhouse gases are equal. Each has a unique potential to warm the planet, but for easy comparison, this team converted all the gases to the equivalent amounts of carbon dioxide. Meanwhile, the total environmental impact was a lot more complicated. Here, the researchers looked at 15 effects, everything from ozone depletion to toxicity to water and resource use, and a lot more. By putting a number on these things and adding them up, they could compare a broad range of impacts at the same time. The downside is that this is a big oversimplification, and they couldn't fit in some important variables. We'll get to those later. But for now, the big question is, what did this study find? Well, the first thing to consider is what it took to make the bags, because producing them is the stage with the biggest impact. Single-use plastic bags are made of petroleum, also known as oil. Specifically, this study looked at a type called low-density polyethylene, and the majority of the impact there came from turning the oil into the plastic material itself. For biodegradable plastic bags, they looked at a material called starch-complexed biopolymer, basically a plastic that incorporates plant starches. Overall, manufacturing these bags releases a similar amount of greenhouse gases as making plastic bags that aren't biodegradable. But there are also some additional effects of the agriculture involved in making the plant starches, like more water, fertilizer, and pesticide use. So just from a production standpoint, biodegradable plastic is actually worse than single-use stuff. Similarly, to make a paper bag, you need to start with a tree. How a specific forest is managed is hard to capture in this sort of comparison, but either way, the process of turning wood pulp into paper can emit a lot of greenhouse gases. This depends on what kind of fuel is used at the paper mill, so the different studies can come to different conclusions about paper bags. According to the Danish researchers' calculations, they have a similar climate impact to single-use plastic. Now, if you've been holding out for the reusable bags to come and blow everyone else away, well, they do, but not how you might think. See, thick reusable bags are also made from oil, and you need more of it to make a thicker bag, so there is a bigger impact. Heavier bags also need more fuel to transport them to the grocery store. And cotton tote bags? These might seem like a green option, but growing cotton requires a huge amount of land, water, fertilizer, and pesticides. On top of that, processing cotton is an energy-intensive process. So when it comes to making the bag, single-use plastics win by almost every measure. In this study, paper edged out single-use plastic slightly when it comes to greenhouse gas emissions, but others have disagreed with that and calculated that paper bags can be worse. And either way, when it comes to production, the worst material by far is cotton. But that said, just how something is produced doesn't really reflect real life. It's not like we're just making bags and watching them sit around in a warehouse. And that brings us to how the bags are used. Using a shopping bag doesn't cause pollution, but it does affect how we compare these materials because, ideally, you don't use your nice cotton bag once and then throw it away. Here, what you have to do to compare different materials is you look at how many times you would need to reuse them to offset their impact compared to using a new plastic bag every time. If we just consider the climate change impact, paper bags and biodegradable plastic bags are roughly the same as a single-use plastic bag. Meanwhile, heavier reusable plastic bags need to be reused at least 6 times to make up for their climate change impact compared to single-use plastics. And cotton bags need to be reused at least 149 times. And this isn't just something the Danish report found. These numbers are similar to the findings of a 2011 study from the Environmental Agency in the UK. To offset climate change impact relative to a single-use plastic bag, they found that you would need to use a paper bag 3 times, a reusable bag 11 times, and a cotton bag 131 times. But all those numbers change if you look at the total environmental impact. If you add in the other 15 categories with toxicity, ozone effects, runoff, and everything else. In that case, in order to be greener than a single-use plastic bag, biodegradable plastic bags, paper bags, and reusable plastic bags need to be used about 40 to 50 times each, and cotton bags need to be reused 7,100 times. That means even if you grocery shop 3 times per week, you need that same cotton bag for the next 45 years to have the same impact as using over 7,000 single-use bags. And this estimate was even higher for organic cotton because organic crop yields tend to be lower. You would need to reuse that bag 20,000 times. So there's clearly an issue with some of these materials. Like, the numbers for reusable plastic bags are well within the expected lifespan. I have reusable plastic bags that I have been using since 2004. But for biodegradable plastic, paper, or cotton bags, the number of times you'd need to reuse them is well beyond how long you would expect an individual bag to last. Now, only the Danish report calculated the total impact like this, so we don't yet have multiple studies to support those numbers. Still, just based on that, it might seem like plastic comes out ahead, and the plastic industry is happy to use this logic and these comparison studies to lobby against the regulation of single-use plastics. But there is one more key variable: disposal. Here is plastic's Achilles heel. There's no good way to dispose of it. So if you add in litter and impacts on marine ecosystems, single-use plastics look a lot less green. It's hard to get good data on what fraction of plastic bags are recycled, but we know it is low, possibly around 1 to 3%. Many recycling programs don't accept them for the simple reason that they get caught in sorting machines. And bags that are not recycled sit in landfills, clog sewers, and pollute waterways. Plastic bags are especially bad since they're easily picked up by the wind and strewn across a large area. They also take a long time to break down and pose a direct threat to wildlife. They can become wrapped around creatures mistaken for food and eaten, or even spread invasive species that hitch a ride. And this is one area that life cycle assessment studies fall short in. They don't have a way of comparing the effects of litter on ecosystems. Regardless, new materials like biodegradable or compostable bags are supposed to solve this problem, but while a 2019 study found that these are better than traditional plastics, after 3 years, none of the bags tested broke down in all environments. Paper bags are biodegradable, so the impact of litter is low, and they're recyclable, but left to break down in a landfill, they release methane, a potent greenhouse gas. For the heavier reusable plastic and cotton bags, disposal should be a smaller part of the overall footprint, since hopefully they've been reused many times. Both can be recycled, but that doesn't mean that they always are. For example, only around 15% of textiles, a broad category that includes cotton bags, end up recycled. And so now, after 3 intense rounds in a surprisingly long episode of SciShow, the greenest bag of them all it's complicated. The best material depends on many factors, including your individual habits, like how many times you reuse each type of bag and how you dispose of your bags. Overall, making single-use plastic bags has a relatively low environmental impact, but waste is a massive problem with no good solution. The best option for the end of a plastic bag's life is to reuse it as a trash bag. Presumably, you would be using something to contain the trash anyway, and if nothing else, the bag is a lot less likely to float away if it's weighed down by all the stuff inside it. Meanwhile, manufacturing paper or biodegradable plastic has higher impacts, but these materials reduce the problem of litter. And heavier reusable plastic bags are a great option if you reuse them enough. Cotton tote bags have by far the biggest environmental impact. They look very green when you've got them on your shoulder. Turns out, that's kind of a lie. They need to be reused hundreds of times to counteract their climate footprint, and possibly thousands if you consider multiple environmental impacts. So we're not saying plastic bags are good. They're not, but it is important to remember that the alternatives have an impact too. It's not worth going out to buy a snazzy new reusable product if you already have one that works. So no matter what your bags are made of, the best way to minimize their impact is to reduce how many you use and reuse them as many times as possible. And when you cannot use a bag anymore, do whatever you can to make sure it does not become litter. It's also worth keeping in mind that despite all of the attention grocery bags get, they are only a very small part of our impact on this planet. But looking at the entire life cycle of a product can be a useful way to analyze nearly...
All right, guys, I think you get the point. If you want to watch the rest of the video, it'll be posted, like I said, next to this. Thank you guys for your attention today. Sorry for that, this was long. That question, I'll put a due date on it, but I think I'm going to have it due tomorrow morning, so you guys get a little bit more time, because this was presented late, because I had to figure out how to record it. Regardless, I'll make it due tomorrow morning, probably 10 o'clock. So let me know if you have questions. You will be posting it on Google Classroom, because I'm not going to try to use the ridiculous Remind app again. That was tragic this morning. So I'll see you guys on Wednesday for another one. Bye.